Hello, and welcome to Feed Your Brain. I am your host, Andrea Paratto. Have you ever heard the phrase, if you don't use it, you might lose it? Did you know this phenomenon can also be applied to the brain? I am joined today by Jean Makesh, CEO of the Lantern Group. Hi, Jean, how are you?
I'm good, Andrea. How are you?
Good. I have a question for you. Is there a way to increase the functional capacity of the human brain? And can we keep our brain healthy?
Oh, absolutely. I think we can. I talked about before where the size of the brain that I have today is not what I had 20 years ago or 10 years ago.
Yes.
And my brain size has increased because of that constant and consistent learning that I have exposed the brain to. See, the most important thing is how the brain would grow. How do we keep our brain healthy? And it's very simple. The key, the way we keep our brain healthy is to actually increase the blood supply to our brain.
Okay.
Increase vascularization.
Okay.
Or maintain the blood supply to the brain. Blood carries nutrition. And every single time I do an activity, just me raising this arm up, so there is a part on the right side of my brain that is directly responsible for this movement. And as soon as I do that, this increased supply of blood carries glucose and oxygen to that portion of the brain, that part of the brain, to those neurons that are directly responsible for this action. And that's how fast it happens. So in my mind, the key thing to keep our brain healthy is to ensure that consistent supply of oxygen and glucose to the human brain, to increase the blood supply, get the blood going. And if neurons then don't get the nutrition, that's when the neurons die. We call it neuronal death. Or it can cause lesions or problems where then it has to be repaired. So as long as we can keep the blood flowing to the brain, we should be good. So how do we go about doing that?
Good question. That was going to be my next one.
Yes. How do we go about doing that? And first of all, number one is activities, exercises. So the brain has, a sensory cortex and also a motor cortex. The sensory cortex is directly responsible for all the sensory elements, all the sensory functions. And the motor cortex is responsible for all the motor movements. So if there's a way that we can trigger the sensory elements, the sensory part of the human brain, and also the motor part of the human brain, like the way I said before, every single time you trigger that part of the brain, blood rushes to that part of the brain. The key is to get the blood supply to the brain. So any and every activity that you can think of that will increase the blood supply to the human brain is a good activity. So that should be your foundation. In what I've seen personally, and I think this should be studied more further, is basketball. Playing basketball, I think, will increase the blood supply to our brain. Playing basketball. You may ask me, why not soccer? Why not football? Why not baseball? All of that does because they all incorporate the sensory elements and also the motor elements. So you've got the sensory functions and the motor functions firing when you play any game. But more so in basketball, the reason I say about basketball is when it comes to basketball, you should learn to dribble with your left and also with your right. Then you should be able to cross dribble, which means that you got to move the ball across your body, midline, back and forth. When you say a good ball handler, that's what they would do. They'll cross the ball back and forth. Now, not only that, they would also cross the ball under their legs. They would cross the ball behind their back. So when you do these things, now behind your back, what you are paying attention to a couple of things. You can't see the ball, right? You can only feel the ball.
Right.
and there has to be a certain pattern.
Mm-hmm.
You can hear the ball.
Mm-hmm.
Okay, that's another sensory element, right? Feeling by touch and hearing the ball. So you when you play basketball, you don't cease to using your sensory components or your motor functions. Then you got to dribble the ball. Now you've got very limited time to make a decision, problem solving, judgment skills, to whom to pass, when to pass, how to pass, dribble the ball. You got to leap, finish a layup or a dunk, or shoot the ball. When you're shooting the ball, you have your movements, range of motion. At the same time, you have to figure out how deep, what the depth is, and you got to toss the ball. You got to shoot the ball in a certain arch. It has to follow. The arc is very important. The angling is very important. So a lot of things you have to do in a very short time, because the basketball court is a lot smaller than a football court or a soccer field or a baseball field. Bigger the spaces, it gives you time to figure things out, to process. It gives you more time. Whereas when it comes to basketball, you don't have much time. And the reason I'm also more interested in basketball is I started looking, basketball players that have Alzheimer's disease or that may have some form of dementia. I couldn't find too many, maybe one or two. So I think, or maybe a few, I would say. I think basketball is a great activity, because anytime you actually move the ball across your midline, or move your arm across the midline, your right side of the brain fires. You do the same thing with the left. Move the right, the left side of the brain fires. When you move your left hand, the right side of the brain fires. So then both the sides of the brain have to communicate with each other to create that coordination. Okay, and to have the quality of movement so that you don't lose the ball. Now, when you're doing all of that stuff, you have to maintain good stable position, which is posture stability, and you have to coordinate, you have to move. That's where the mini brain cerebellum kicks in. So I think we need to study basketball a little further. I think basketball could be therapeutic to keeping the brain healthy when it comes to brain rehabilitation. So that particular activities, I think, can help with neurogenesis and neuroplasticity. Now, so those are some of us that don't like to play basketball. What do we do? Right? What do we do, right? So I would say, look at the brain as a muscle. Okay. You want to grow the muscle, right? When you want to grow your biceps or your triceps or your chest muscles or your pecs, you subject the muscle. You got to stretch the muscle. You have to create a tension for the muscle to grow. The way you do it is either through isometric or isotonic exercises. You use the weights, repetitions. It depends how, depending on the size of the weight, the weight of the weight, the frequency, the repetitions, the number of repetitions, that all matters. So in a similar way, when you look at the brain, you want to stretch the brain. You want to create the tension. And the way you go about doing that is actually through new learning.
Okay.
New learning that really strengthens your, reinforces and strengthens your cognitive health. Trying to learn a new language, trying to learn a new skill. That's something that you're not comfortable with. In my mind, like the way you build your muscle, you have to subject your muscle to, different weights that the muscle is not comfortable with, causes pain and discomfort, lifting different sizes, different weight sizes, different frequencies, which means different repetitions. More repetition, less repetition, more weight, less weight, all of that matters. So the most important thing is when you may want to look at the brain in a similar fashion. Those some of us that do not like activities, how can I stretch the muscle? How can I stretch the brain muscle? How can I stretch the brain? Is by subjecting to new learning, things that are difficult, that is challenging, hard to learn. So if you don't like doing, a certain type of puzzle, I would encourage you to do that. Try it out. Learning a new language when you're 40 is not fun. Try doing that, or learning to play an instrument when you're 60 or 70-year old. Just holding the guitar strings, can be very, very painful.
Yes.
So I would say that challenging our brain to new learning would help with increasing the blood supply, strengthening what we have, and recruiting new neurons. When it's new learning, now you have to use a different part of the brain. So you'll have to recruit that neuron. You got to wire that neuron, into the system. So that's how you expand. When I say, health of the brain, strengthen the brain, expand the brain, what I mean by is like increasing the volume of the brain. The way you increase the volume of the brain is recruiting more and more neurons, so that you keep the neurons healthy. Because the brain is 3 pounds heavy. For every heartbeat, 20 to 25% of blood supply goes to the human brain. Think about it. I'm about 180 pounds. Okay. 25% of my blood supply for every heartbeat, 20 to 25%, goes to 3 pounds. And the poor rest 177 pounds they only get 75%.
Huh.
So that's how powerful the human brain is. And the one way to keep it healthy is to increase the blood supply. So anything and everything you can do. I got to tell you something very interesting. I think women are at a better advantage when it comes to. I think they've got an upper hand when it comes to.
This is getting interesting.
When it comes to expanding the human brain. The reason being is, see, when a man and a woman are subject to a phonological task, which a phonological phonic is like sound, different sounds and stuff like that. Women use both the sides of the brain to perceive that sound, perceive that that stimulus. Whereas men use only one side of the brain, which is the left brain. I use only one side of the brain, whereas you use both sides of the brain. So tasks and activities that can motivate or use both sides of the brain, incorporate both sides of the brain, is fantastic to increasing blood supply. And that's why I felt that basketball is one game or one sport, I should say, helps in recruiting more neurons. When it comes to physical activity, if you can subject, like for example, if I'm having you engage in an activity, if there's a way that I can maximize your sensory components, your vision, your hearing, and at the same time also your motor functions. Like for example, another good activity that I like is the beanbag. Throwing the beanbag, right? So you've got two teams standing, parked on the opposite side, and the cornhole, right? The cornhole beanbag, right? So you throw the beanbag. So when I'm throwing the beanbag, now not only my cerebellum, my brain, my mini brain is responsible for holding my posture.
Right.
I don't want to slip and fall, and at the same time I'm actually holding the beanbag, and I'm throwing. I'm using vision. Okay, I try to figure out how deep, how far, how much force I got to use, how much energy I have to exert to throw that beanbag. At the same time, I'm engaging with my friends, talking, they're joking, and the team that I'm playing with, they're challenging me. And so now I'm not only now vision, I'm hearing, I'm talking, I'm feeling the beanbag with my hands. So I pretty much use all my 5 senses. Not 5 senses. What if I have to lick it to use my 5th sense? I'm not going to lick
Don't
the
do
beanbag.
that.
But standing and the posture and the strength that I need to throw the beanbag, toss the beanbag, the coordination, the range of motion, all of that fires the human brain, increases the blood supply. So that's the key thing. Anything, when you're trying to create a task, Even if you have your senior working on a puzzle, challenge them to work on the puzzle while standing, while sitting, because it works on your trunk stability, posture, little things. So I truly believe that we have direct control over the size of our brain. We dictate how big our brain should be, and we can do that.
You've used a phrase before, cognitive reserve. Can you explain that a little bit?
Oh, absolutely. So the way I look at cognitive reserve is, I'm just use simple terms here. Let's say that if my brain has 100 neurons, well, my brain doesn't have 100 neurons. My brain has over a billion neurons.
Yeah.
And the neurons, when you connect the neurons, there are connections that type more than one neuron. They're called as, we call it connections. It's called as, we call it synapses, the connections. There are over 1 trillion connections. So when you line up all the neurons, and tie them together and you line them up, you can actually go to the moon and come back. That's what is actually in our skull, the 3-pound brain. That's how many neurons we have. That's how powerful those neurons are. Now, the way you go about, in my mind, is creating cognitive reserve is, what is that I can do to recruit every neuron that I have in my human brain? Activate every neuron. Just moving my finger a little bit activates one part of the brain on the left side. Doing a cognitive task will activate a certain part of the brain. So what can I do to keep using my brain? So if you don't lose, you snooze. There's something called as disuse atrophy. If you don't use it, that part of the body weakens, becomes less weak. And the more you use that a part of the body, that stays strong and becomes stronger. So what is it I can do to use every part of the brain? I mean, is it humanly possible? One way to do it is actually through new learning that I talked about, activities and exercises. So cognitive reserve is essentially we expand the surface area of the brain. We continue to what is the word I'm looking for? Is figure a way to recruit more neurons, and the process of neurogenesis, birth of new neurons. It's very important. Stress is a big factor. Stress do kill neurons.
Really?
Yeah, stress do kill neurons, because when you're stressed out, there are certain hormones that are produced in the human brain that actually kills the neurons, and that's why when you're stressed, you think about it. When you're stressed, you try to recall a memory. You try to process information when you're stressed.
This is not good news for this day and age. It's very stressful today.
Exactly. So, or you try to articulate something when you're in immense amount of stress.
Yeah, my words don't work right. I jumble. I feel like my brain speaks faster than my mouth can sometimes.
Exactly. Stress plays a huge role, and it's not good. Being stressful is not good. So it prunes the neurons. It kills the neurons. So you really, stress is something that we have to avoid. Now, by doing that, you're building the cognitive reserve. Okay. By learning new things, you build the cognitive reserve. So let's say I have Alzheimer's disease and I have the brain markers, the plaques and the tau protein. And it's going to go through the course. My brain is going to go through the normal course of the disease, right? But if I expand the surface area of the brain, I cannot stop the progression of the disease, but I can slow down the progression of the disease. And for example, if you're standing in a 10 by 10 room,
okay.
I'm standing in a 10 by 10 room.
Okay.
And I pour a jug of water in one corner and I let the water trickle down, flow across the room. So a 10 by 10 room, I pour a jug of water in one corner. By the time the water comes from one corner to another, let's say it takes about 10 minutes.
Okay.
Let's say it takes about 10 minutes for the water to trickle down across. Now, let me take the same jug of water and I pour it in a space that's about 4,000 square feet.
Okay, that's bigger.
That's very big. That's bigger than a 10 by 2. Now I take the same jug of water and I pour it in one corner. How long do you think that how long it's going to take for the water to trickle across the room?
A lot more than 10 minutes.
A lot more than 10 minutes, right? So I would see the brain, from that perspective. Do you want a brain that's 10 by 10? Or do you want a 4,000 square foot brain?
I want the 400 square foot brain.
Yeah, you want the 4,000 square foot brain.
4,000, yes.
Right? Yeah, we would love the 400,000 square foot brain. That would be amazing.
That would be great.
Yeah, that would be amazing. And the jug of the water is nothing but Alzheimer's disease.
Okay. That makes sense.
So with 4,000 square foot, you've got more reserve. You've got the capacity, more bandwidth, for the water to trickle down. And it's going to take more than 10 minutes for the water to trickle down.
That makes sense.
So it's important for us to improve our cognitive reserve. And studies have shown that, folks that even though they had the plaques and the tau protein, they never manifested the symptoms of Alzheimer's disease. And the only reason they could think why that would have been the case, yes, the amyloid plaques and tau protein is still a hypothesis. The brain marker is still a hypothesis. We think that's what is causing the disease, right? We don't know for sure. It's still a hypothesis. Still, when they looked at the human brain, when the study showed that some of the brains that they looked at, they had the tau protein and they saw amyloid plaque. But those individuals, when they were living, did not manifest any signs or symptoms of Alzheimer's disease. The only reason they think that could have happened or may have happened is because those individuals had a bigger cognitive reserve. So, see, the beauty of the brain is not only it's a very powerful organ. The brain actually has the capacity to self-repair itself.
That's amazing.
So anytime there's a lesion or anytime, there's a vascular compromise, it's going to figure a way to self-repair. It's called cortical self-repair. And sometimes when it's not able to, that's when you start seeing the symptoms. You're not able to move your hand or able to move your thumb or things like that, or you're having difficulty with certain cognitive functions. So the brain does have the capacity to self-repair. We have to give the brain a bit more chance to repair more, longer. And the way you would do is increasing the blood supply and increasing the cognitive reserve.
Well, that's awesome and good news for all basketball players.
Oh.
They're gonna be doing great. Thank you very much. That was very interesting.
Thank you, Andrea. Thanks for having me.